Guys, today we're talking about carboxylic acids. So this is the last group that we need to talk about. Kind of exciting. I hope you guys are excited. Here's what a carboxylic acid is going to look like. So it's got this R chain, which as we know, R is just any number length of carbons. So you'll see, for example, down here, oops, you can't see that. Down here, I've got my 5-carbon pentane just chilling over there. What a carboxylic acid does is it's going to change one of these ending carbons. So it can be the outermost on the left side or the outermost on the right side, right? Remember, those are both considered carbon ones. So it changes one of the carbon ones. Here's what happens. Instead of having your normal 3 H's around the last carbon, we're going to get rid of those guys. And one bond, we'll do this in purple. One bond is going to become an OH, which is like an alcohol, right? Alcohols end in OH, as you can see right here. Alcohol ends in OH. But then a carboxylic also has a double bonded O attached to the ending carbon. So this is what a carboxylic looks like. It's got 5 carbons here, a double bonded O, and an OH. Now, this could have any number of carbons. It could have 1, where in that case it would just be, this guy right here. Let's duplicate that. And then in this case, we would just add 1H over to the carbon. This would be a meth prefix, so we would call this methanoic acid. And then over here, for example, with my 5 carbons, since 5 is pent, we would call this pentanoic acid. So, and then this would be meth for 1 carbon, enoic acid. So as you might be able to tell here, the ending is different. The ending for carboxylic acids is anoic acid. Cool. One of the other things you'll notice here is that there's no arrow going down to the which carbon is the functional group on, since the carbon's always going to be on what we call the outermost. So what that means then is that we never put any numbers next to carboxylic acids because it's always going to be on the outermost. So if you see 1 pentanoic acid, that is incorrect. We do not want that. Sound cool? Just to be clear here, it could easily be on the outermost, so that would be, in this case, this carbon, or it could also be on the other carbon. It might look a little bit different if it's on the carbon on the left side, so let me just show you what that would look like then. First, I'm going to redraw pentane, just so that it looks nice and normal, and then we're going to erase the 3 hydrogens over here. Okay. So, back to purple. Our OH is going to look like this, because remember, it's the O that bonds to the carbon, not the H. So you would write it actually as HO if you're making the bond to the left side. And then again, we double bond the O. The O can be double bonded on top. That's usually what happens. It could be bonded down below like this. Again, it doesn't really matter. It's just some of these are kind of conventions that we like to show. Typically, we'll show the double bonded O on top and we'll show the OH coming on this right side over here, but that doesn't necessarily mean that that's the way it is. So yeah, anoic acid is carboxylic acids. It doesn't have a number, so that's nice. And then it's always on the outermost. That's carboxylic acids in a nutshell. So hey, look at this progress we've made here, folks. Oh, everything at this point in time should be filled in on your flowchart, and it should just look beautiful. And keep in mind here, yeah, this is how we name everything. So congratulations on completing the flowchart. Hope you have a great rest of your day, and we will catch you next time. We'll see you then.